Jai Hind students. In this lecture we are basically going to concentrate on Tdm Pam system, which is a digital multiplex system used in telemetry systems. In the previous lecture we understand about the analog multiplex system which are FM FDM multiplex system. For that we studied about the frequency modulation and demodulation technique, frequency division multiplexing and demultiplexing techniques, and then combinedly a analog multiplex system for the telemetry system. Today we are going to concentrate on the digital multiplexed system, and as per this digital we are going to use digital modulation technique and digital multiplexing technique. We already understand or studied the time division multiplexing, which is a part of digital multiplexing. So, here we are going to concentrate only on the digital modulation part. Starting from the pulse modulation, this is the another type of analog modulation, but in this pulse modulation actually we are using a pulse signal to modulate the message signal. So, in the pulse modulation is the process of changing a binary pulse signal to represent the information to be transmitted. And the primary benefits of transmitting information by binary techniques are basically in digital techniques we have a noise tolerance and also ability to regenerate a degraded signal, because whenever noise introduced in the signal will be degraded, but if we are using the binary techniques for the transmission of information, we can easily regenerate the degraded signals. So, what is pulse modulation? Actually this is the input analog signal, and this input analog signal is going to be modulated by using a pulse, and that is the pulse. As per the normal signal, this pulse have also three parameters. First one is amplitude, second one is position, or third one is width, that is the width. As in amplitude modulation we are varying the amplitude of the carrier. In phase modulation we are varying the phase of the carrier. In the frequency modulation we are varying the frequency of the carrier. Similarly, in this pulse modulation technique we are dividing the pulse modulation technique in three types. First one is PAM, pulse amplitude modulation, second one is pulse width modulation, and third one is sorry, pulse position modulation. How it is going to be performed? You can easily see here. This is your carrier signal, this is your carrier signal, this is your input signal. What you are doing here? You are going to modulate this pulse as per this input signal, means these pulses are going to take sample of this input analog signal. If you are talking about the pulse amplitude modulation, means position and the width of the pulse will be kept constant, only the amplitude of the pulse will be vary in accordance to the instantaneous value of the message signal. Similarly, when we are varying the width of the pulse as per the instantaneous value of the message signal, you will get this pulse width modulated signal. In that you can see the difference, that amplitude for the all pulses is same, but the width is varying here, here. With positive, this width is increasing, but when there is a decrease in the input voltage, the width is also decreasing. This is known as pulse width modulation. And when we are talking about the pulse position modulation, you can see here the position of the pulse starting is also going to be changed. So, you can see here you are applying a analog signal as the input signal, and you know that all the input coming from the various sensors are analog in nature. You are applying that analog signal to this pulse amplitude modulator or pulse width modulator or pulse position modulator and getting the pulse shaped or binary output at the end. So, you can see here sampling is a very important part of this pulse amplitude modulated system, because you can see that what is actually we are doing in this complete diagram, we are taking samples on individual time interval, and that individual time interval are fixed by these pulses. You are getting the pulse at T1, T2, T3 time, and for each T1, T2, T3, T4, T5, T6 and Ts times you are generating the samples. The amplitude of the sample is going to be governed by the instantaneous value of the analog modulation, sorry, analog input. So, to understand this more, we going towards this sampling part, because sampling is somehow equivalent to the pulse amplitude modulation, or in the simple way or in the simple words you can see that you can call whenever we are converting this continuous signal into the discrete one, this is called sampling. What you are doing here, actually in this part you are taking an analog signal and going to sample it after every Ts second. That Ts second is referred as sampling interval. So, the sampling frequency is Fs is equal to 1 upon Ts, means you have this analog signal, you have a impulse train, or we can say that unit impulse train, which is directly going to multiply, and we are getting this sampled output. So, on this basic phenomena of sampling, there are three basic sampling methods. These three sampling methods are ideal sampling, natural sampling and flat top sampling. When we are talking about the ideal sampling, this is by using impulse signal, means unit impulse signal. But here I want to mention one point, any pulse which is not having any type of width cannot be practically possible, means this ideal sampling is not practically possible, because we are using unit impulse train to perform the sampling, and unit impulse train is practically not possible. So, this first technique of sampling, which is known as ideal sampling, is a ideal technique and which is not practically possible. So, the first practical possible technique of sampling is natural sampling, and that is actually we are using a pulse train of toe width, means you are having this input signal, this pulse train, and that pulse train is going to be multiplied with this signal, and we are getting this kind of signal. You can see here the upper part of this pulses are continuous in nature. So, this is called natural sampling, a pulse of short width with varying amplitude. But again there is a problem. Each sample have a continuous part on the top of the pulse. It means sample is not specifically giving you a sampled value. It has a group of values, and that is not fulfilling the basic aspect of the sampling. That is why we are using flat top sampling. The flat top sampling is same as this Pam signal. What is we are doing here? Actually we are here generating the various sample for this input signal, and each sample have a flat top with the width 2. So, this is the most suitable way of sampling and known as sampling flat top sampling technique, and which is also known as the pulse amplitude modulation. So, how it is going to be performed? You can see here we have this diagram. This is representing the ideal sampling. You can see here we are using impulse train of Ts interval. For each Ts interval you are getting the samples. When you are talking about the natural sampling, you can see here we have the sampled output, but have some continuous signal part in this. But when we are talking about the flat top sampling, we have a flat top sample for individual analog signal. So, this is the most suitable way to represent a input signal. So, this is pulse amplitude modulation. Amplitude of the pulse carrier varies proportional to the instantaneous amplitude of the message signal, and the width and position of the pulses are constant in this modulation. Here you can see that easily. This is the modulating signal, this is the carrier pulse train with a fixed width of 2, both are going to be multiplied, then we are getting a natural Pam signal or the flat top Pam. To generate this flat top Pam, we have a different approach. That different approach is how to be governed, that you can here easily understand that. To generate this flat top Pam, first of all you have to multiply this modulating signal with the impulse train, unit impulse train. This unit impulse train give you the ideal response or ideal sampled response of this input signal. Then this impulse response is performed convolution with this carrier pulse train, and as per the convolution property we are going to get this flat top sample. Means in the ideal sampling case you are taking a impulse train of Ts second and directly getting the ideal sample. In the natural sampling, you are getting a pulse of tau width, going to multiply it with the analog input and getting this natural sampling. But in the flat top sampling, first of all you are performing the ideal sampling and then you are performing convolution on this impulse response with this carrier pulse train and getting the flat top Pam output. So, in the digital multiplex system, as I told you earlier, there are two type of system, Tdm Pam or Tdm PCM system. Tdm is stand for time division multiplexing and we already discussed the pulse amplitude modulation technique. So, the first multiplex or digital multiplex system which is used for the telemetry system are Tdm Pam system. In this Tdm Pam system diagram, you can easily understand all the points. Here, this is the transmitter part of the telemetry system. You are getting the various message input 1, 2, 3, 4, 5 n tak. These input messages are coming from various sensors. These sensors are generating low signals, low voltage signal or we can say that weak signals, and that signals are applied on the low pass filters that are LPF. These low pass filter are basically using the anti-aliasing filter. Here I want to mention you one point. For the sampling or the ideal sampling or the natural sampling or the flat top sampling, there is a condition which condition is called Nyquist criteria, which state that Fs is always greater than equal to twice of Fm, means the sampling frequency will always greater than or equal to the twice of message frequency, otherwise there is a problem of overlapping the signal which is called aliasing. So, this particular first LPF low pass filter is used here to maintain this sampling theorem, and this is designed in such a way that the low pass filter will work as anti-aliasing filters. Then these inputs are applied to this a commutator switch. This commutator switch is used for the time division multiplexing. This commutator switch is going to be governed or going to be operate by using clock signal. For each clock signal, the position of this commutator switch will be changed and that change will give a constant time slot to individual message inputs. Means for first, second it is connected to the message input 1, for second, for 2, similarly to the n. So, this commutator switch is responsible for the time division multiplexing. Then this time division multiplexing or time division multiplex output we are getting here, that is in this form, as this is the A input, means first sensor input, this is the B input from by the blue line, this is second sensor input, C is the third sensor input. When we are performing the pulse modulation by using clock pulse and the different switches, we are getting this kind of composite signal. This composite signal then pulse modulated by using pulse amplitude modulation technique, and we are getting this composite signal which will transmitted through the channel, communication channel. That communication channel may be wireless or wire. Then at the receiver side, means this is the transmitter side of a Tdm Pam system, whether this is the receiver side of a Tdm Pam system. At the receiver side you are getting this composite signal and going to demodulate, pulse demodulate this composite signal and getting various message signals. So, in this part we are using a decommutator switch. As I told you in the previous lecture of synchronous time division multiplexing and asynchronous time division multiplexing, I told you synchronization plays an important role in the time division multiplexing, because the both multiplexing and demultiplexing on transmitter and receiver side is going to be governed by the clock signal or the synchronization pulse. Because if your commutator switches are not working in a synchronized manner, then the demodulation of correct information or receiving of the correct information is not possible. Because on one time here the commutator switch is sending the information of message input 1, but because of non synchronization at the receiving side, at the same time the decommutator switch receiving the information of message input 2. This will lead to confusion. That is why synchronization plays a very important role in this complete digital multiplex system. So, then using this decommutator switch we will get the various inputs, then these various input applied to the low pass filter. Again these low pass filters are governing by the reconstruction filters, and these reconstruction filters follow the same condition of sampling, that is Fs is greater than equal to twice of Fm, because in any case if Fs is less than twice of Fm, aliasing problem will occur, aliasing problem will occur, and this aliasing problem will create distortion or the deformities in the received signal, which will give us a error and the original signal will not be recovered. So, this is the Tdm Pam system. Similarly, if we are using pulse chord modulation in this Tdm system, then it will become Tdm pulse chord modulation system. This is also a digital modulation technique. This technique is more popular because in pulse chord modulation, which is also known as analog to digital conversion, means you are getting this analog signal and getting the 1011 form of digital output in the pulse chord modulation system. So, here you have to understand that pulse chord modulation system is very much famous for this digital multiplex system used for digital telemetry systems. In pulse chord modulation, basically analog voice data must be translated into a series of binary digit before they can be transmitted. With pulse chord modulation, the amplitude of the sound wave is sampled at regular interval and translated into a binary number, or the difference between the original analog signal and the translated signal is called quantizing error. Here you have to understand one point, that in pulse chord modulation you are going to perform three basic steps. First one is sampling, second point is quantization, and third one is encoding. whenever you want to perform pulse code modulation, you have to follow these 3 steps, because these 3 steps are going to convert this analog signal into this binary digit. So, in the next lecture actually we are going to perform this pulse code modulation first by using these three techniques. Then we are going to combine this with the TDM technique, and we are getting the TDM PCM system, which is a digital multiplex system. So, always remember, in both Tdm Pam system or Tdm PCM system, sampling plays an important role, and all the filters or the other circuits are basically following the Nyquist criteria, which is Fs is greater than twice of Fm. The only difference between these both techniques are related to the bandwidth. So, in the next lecture we will discuss about this TDM PCM multiplex system. Till then, thank you.